All right, wait, what do you have there?
Bolts.
Okay, those are like 3/4 inch. So this section of my house has been kind of a disaster because I moved into my house like really fast because someone was being kind of a, doesn't matter. Like I had to move a whole bunch of stuff into my house really fast. So there's this huge section over here that just got stuff piled into it. And now my kids and I are going through it and they're helping me organize all this stuff. First, so I can reclaim this whole area to, turn it into some giant robot building sections. Like I'll probably build it back there and I gotta organize this shelf and stuff. Anyway, we're also getting all these bolts out. So this is a whole bunch of stainless steel bolts. There's 2 different sizes, these and longer ones there. Most of them are the longer ones. Anyway, this was from several years ago. I saw on Craigslist, some guy was selling 3,500 of these and some slightly longer ones for 250 bucks. And I was like, 7 cents a piece? Are you kidding? I'll take them all. And then I have a whole bunch of other bolts. Oh, I got a call. So I've been thinking about what options I have for just a bunch of giant robot parts. I do have some stuff here for a bunch of the leg parts, but there's a bunch of the... Hey, yeah, whoa, don't, no. Okay. Oh, kids are getting into stuff. I gotta go. I needed some not kids for a little bit, so I gave them a broken inverter to take apart, and they will totally strip it and like take out the fans and separate all the pieces. It's great. I've been a little bit stuck for the last week or two trying to figure out how to make this next section down here. There's a bunch of reasons for that, but the major reason, there's 2 major reasons. One, just the geometry of this slewing bearing means I have to take something that was originally here and move it out so it has something good to attach to. And the other thing is right in here, there's like this rectangle that attaches to the main body of the robot here and at the bottom. So it pivots that way there. And then it attaches to the leg, like kind of through the middle there, so the leg can move up and down. And this thing, that rectangle, has to support a lot of weight. Sometimes up, sometimes down. Now in a plastic model, the whole thing can just press up against the piece above and below, and it just rubs plastic against plastic because there's not that much pressure. However, on the big steel version, it's going to be like literally a ton of weight, like 2,000 pounds, 1,000 kilograms. I can't just ignore that and let the metal rub on the metal with that much pressure. So that changes the strength requirements for this rectangle, because I can't just presume it's going to be supported on the side here and down there by rubbing up against the main body. It's going to have a bearing here, and I think a thrust bearing around it, and that piece going across the top there is going to have to be strong enough. Yeah, it's... So first I was thinking, all right, I should just make this out of steel. However, I really don't want to make anything on the outside out of regular steel. Parts on the inside, fine, because they're protected. But anything on the outside, it's going to get rained on and stuff. It's going to rust. Even if I paint it, it's still going to end up rusting. So I want all the exposed parts to be aluminum, or stainless steel. So I do have some pretty heavy-duty aluminum stuff around here. These things. Do I have one? Yeah, right here. Yeah, that's some pretty heavy-duty stuff right there. But the aluminum is just not the right material. I think it's going to wear out too quickly. So, and I don't want this thing to be like something that I make works long enough to get on video. No, I want this thing to like work. I want to be able to use it, whatever. So I started looking online at the place where I bought those tubes and pipes and stuff. Yeah, a while ago someone donated some money to me and I bought a whole bunch of like tube stuff and sheet metal from this place in Panama City. It's called Carbone. And I looked on their website and they have some stainless steel square tube. They have like 1.5 inch up to 4 inches. 4 inches is like $350 a month, forget. It's funny, the price difference between the 4 inch and the 3 inch is like more than double. But I don't know. Anyway, and it's 1/8 inch wall thickness, 3 millimeter wall thickness. So it's pretty heavy duty. So I think that's what I'm going to use. I think I'll get some 2 by 2 inch, it's like 5 centimeter with the 1/8 inch, 3 millimeter wall thickness. And they come in 6 meter lengths. Those should be strong enough to build the thing. And that's kind of where I was last night. And then I went to sleep and then I drew this thing. So then this morning I was like, well, yeah, just like this, make square. I mean, it's not complicated at all once you have the right materials. And then put a bearing at the top, probably bolted in, and then a thrust bearing on top of there, like, well, around there. And the thrust bearing will push on this, and then it'll push on the bottom of this thing here. And this will be probably that 2 inch square tube. I'll have to turn it into a hexagon with all the correct dimensions. And then, I'm not sure if the drawing is coming out right, but these are like circles cut in so that bearing can fit right in there. So that bearing fits right in there, and then the thrust bearing presses on the outer part. And it doesn't have to touch anything out here. It's fine as long as it's there and there. And then, you know, every spot there's a corner, there's a piece that comes down. And that's, you know, this piece here. And then probably the bottom basically the same as this. And I'm not sure if I'm going to weld this connection here or bolt it. I don't know. Whatever. I just need to get the material first to do it. Now, the reason I didn't immediately go to this choice is because it's kind of hard to buy stuff from Panama City. Like, I'm all the way at the other end of the country. So they have a delivery truck that'll bring stuff out here. Not to my island, obviously, though. So there are a few different places they can deliver. And it's actually easier for me to order something from the United States, have it delivered, because then it gets delivered to a warehouse and it can sit there until I go pick it up. So if I can't get there right when it gets delivered, I can come, you know, a couple days later, whatever, it's fine. But if I order stuff from Panama City, they're not delivering to some warehouse. I need to meet them. And that's a boat ride. Over a 10-mile boat ride, depending where I'm going, but at least 10 miles, over 10 miles to go. And if there's bad weather on that day and I can't go, then yeah. So you see the problem. Like when they deliver stuff, I have to make sure I can get there and pick up. But yeah, I'll just have to plan when there's a calm, decent weather looking week. And if on the day they're delivering the weather sucks, I just gotta go anyway. Regardless, I'm pretty sure that's what I'm gonna do. I'm gonna order those things, and that means I can move ahead with my model here. And I do have the full-size bearing here. However, I'm not quite ready to start making the full-size parts to attach to it yet. I'm starting to deviate from the last good design. Like I'm changing some of the dimensions of stuff, and the way this thing works is if you change one thing, you have to change like 30 other things that they're all connected, right? I need to make a bunch more of the model and make sure I get everything worked out before I start making the full-size one. Because it's way easier to come back and say, oh, I need to change something on this than it is to do the full-size. Besides, the sprockets are still on their way here, which is probably a good thing they didn't make it on the last container, because I probably would have gotten excited and put the whole thing together. All right. So let's figure out what to put under this. All right, thrust bearings. Oops. Where'd you go? Let's see. Yeah, 2 bearings, 2 washers. That goes together to make that, which is... Alright, dimensions look fine. Comes in a 2-pack. Okay, this is a stripped down picture of the toy version of these robots. And I've been using this to kind of get the measurements and, you know, relationships between parts, ratios and stuff. But I'm about to go way off this. I'm not going to be able to use it anymore. But I do need the proportion of... The legs are not symmetrical, so this is one of those rectangular boxes, and this is one as well. But this one is wider than this one. Okay, this almost hexagon shape is the part, or at least the angles and everything of the part I need to build. But then in the background, I've got where the screw holes are, the threaded holes. So I want to get as many of these threaded holes inside here as possible. I think if I rotate this screw hole drawing a little bit, I can get some more of them in. There's 2 here, only 1 here, but it's right on the edge, so I want it to come this way a bit. Probably not enough to be able to get... Alright, let me see. Okay, if I rotate this, I can get 1 screw hole right here, and then 2 at this corner. It's like that. Yeah, then I can get 2 here, 1 there, 2 there. I'd like to get more screw holes in though. Let me see if I make this a little bit bigger. Yeah, maybe do that. Oh, go away. No, what just happened? No, stop it. Okay, if I do that, I can get 2 screw holes at that corner and 2 screw holes at that corner. Fine, that's pretty good. Alright, I think that's good. Let's blow this up. Make that 2 inches. That's what it's supposed to be. Right, okay. I got 2 screw holes at every corner. Excellent. Okay, and at this end of things, I need a bigger hole so I can actually get the bolt in there. And that should be good. Too bad I can't just send this to some magical make it perfect machine. Oh, that would be cool. Oh, that's gonna happen in like 30 years, and I won't have one. Maybe I will have one. Okay, put that on there. Bolt it in with the holes. I'm not putting the bolts in the picture though. That looks good. Now I need some weird thing sticking down. Do I make them one solid piece with this welded on? I don't know. Alright, I just need to weld those suckers. Right. Okay, and that's the hole for the bearing to go. Just wait, zoom in a little more. There we go. Yeah, bearing goes right in there. And it doesn't have to have that much pressure going that way. It just needs to fit in the sides there. And yeah, it has mostly pressure going sideways. And then the thrust bearing will press on this part. And that's the one that'll do that force. Okay, and there's the bottom piece. And that has to get bolted onto here somehow. Maybe some angle pieces. I don't know. I'll figure that out later. This is the 3D printer version, so I have something to print out tomorrow. Great. The 3D printer version is a little different. You know, I'm just gonna get screw holes to screw into there, and these things are a little different shape, just to kind of accommodate the plastic in the 3D printer. Mostly the same though. That looks a little tall to me. I don't know, is it too tall? Whatever. This is the scale model. This is where I'm supposed to do all my screw-ups. Good.